Hello students, we know organic compounds are different types, maybe cyclic, acyclic. Cyclic compounds may be aromatic or alicyclic. Already we have discussed things. Aromatic compounds, they possess important characteristics. They possess the particular properties that is called aromaticity. That is called aromaticity. Aromaticity. This is the property of aromatic compounds. Generally, aromatic compounds means they have some common properties. That aromatic compounds are planar in shape and they have low enthalpy of combustion, low enthalpy of hydrogenations, and when they burn, it produces sooty flame. So these are some important properties of aromatic compounds. But aromaticity, that property, one important characteristic of aromatic compounds, that it obey Hockel's rules. If they possess Hockel's rule, what is the Hockel's rule? Hockel's rules means all aromatic compounds, if the organic compound is aromatic, they must have 4n plus 2 pi delocalized electrons. That means that number of electrons, 4n plus 2 pi electron, must be delocalized in the cyclic ring. So in the ring, it must be delocalized. There is no obstruction in the delocalization. It should be circulating throughout the ring and it must have 4n plus 2 pi electrons. And this is called Hockel's rule. Every aromatic compound must obey Hockel's rule. That means it must contain 4n plus 2 delocalized pi electrons. It must be delocalized. It may contain 4n plus 2 pi. If it is not delocalized, it is not aromatic. So, on the basis of these variations, these deviations, if it is obeying Hockel's rules, if it obeying Hockel's rules but not planar, if it is not planar, so it is not aromatic. So, on the basis of particular properties, this aromatic character three types, that is aromatic, non-aromatic and anti-aromatic. Aromatic, non-aromatic and anti-aromatic. Aromatic means it must obey Hockel's rules that contain 4n plus 2 delocalized pi electrons, and molecules should be planar. It is very important. Both conditions must satisfy. Planar must be planar and must obey Hockel's rule. These two satisfying means this is aromatic. Non-aromatic means it do not obey Hockel's rules. Hockel's rules it do not obey. Hockel's rules do not obey means that is 4n delocalized, completely it may contain 4n plus 2 pi electrons, but if it not delocalized, that means complete delocalization is not there, that means it is not aromatic. So non-aromatic means do not obey Hockel's rule. All points it should satisfy. These 4n plus 2 pi electron must be delocalized. Then molecule may be planar or non-planar. That is not important condition for this non-aromatic. Non-aromatic means if it deviates from Hockel's rules, then it is non-aromatic. It may be planar or may not be planar, but if it deviates from Hockel's rule, if deviation from Hockel's rule, that is non-aromatic. Then anti-aromatic means molecule is planar. This is very important. It is planar molecules and 4n pi electrons are there. Number of electron, it is 4n pi electrons, and these electrons should be completely delocalized. These 4n pi electrons should be completely delocalized and molecules should be planar. Then it is called anti-aromatic. So anti-aromatic means totally it is not obeying the Hockel's rules. Because Hockel's rule is 4n plus 2 pi, but it contains 4n pi electrons. And this 4n pi electrons is also completely delocalized. Like your delocalization, it is completely delocalized, but number of electron is 4n pi, not 4n plus 2 pi. That's why it is called antimaret. Let us discuss some examples of aromatic, non-aromatic and anti-aromatic compounds. And these are very important for your competitive examination in different JEE and NEET examination. Also, this type of question will be asked. You have to count the number of 5 electrons, then whether it is satisfying Hockel's rule or not. So, aromatic, non-aromatic and anti-aromatic, we have to see, and we have to observe which property is satisfying. Let us take the examples. So, this compound, this is a cyclopropanyl cation. This is having one double bond. Cyclopropanyl cation. If you see the number of pi electron, it is 2 pi. 2 pi electron means when n is equal to 0, when n value is equal to 0, 1, 2, like this. When n value equal to 0, that is first is 2 pi. So it is satisfying 2 pi electron, and this 2 pi electron is delocalized. It can be go these sides or it can go this side. So it is delocalized. As it delocalized and having 2 pi electrons, and it is also a planar molecule because it is a carbocation which is planar in shape. So satisfying the Hockel's rules and the properties of aromatic. So it is aromatic. And this one also, cyclobutynyl dication, it is also delocalized. This side or this side can delocalize, and having 2 pi electrons and delocalized, a molecule is planar, that's why aromatic. And this one also, you see, it is also delocalized. You see this one, then this one, then this one. So it is delocalized. This, and how many pi electrons? 2 pi. This is also involved in the formation of pi. So 2 pi, 4 pi, and this 2 pi, that is 6 pi electrons. As it has 6 pi electrons and delocalized 6 pi electrons and also having planar shape because it is forming the resonance. So this molecule also planar, although it has lone pair, but involving the pi bond conjugation, that's a planar, that's why it is aromatic. And this compound, that cyclopentadiene anion, it is also delocalized. That's why it is how much? 6 pi electron. 6 pi electron means it is also aromatic and completely delocalized. And in this lone pair electron involved in the pi bond conjugation, that's why it is also aromatic. And this benzene, already know 6 pi, it is aromatic. And this is naphthalene, how many? That is 10 pi, aromatic. And this is how much? That is 14 pi. Benzene, naphthalene, anthracene, like this. And this is also aromatic because 6 pi electron which is completely delocalized. That's why this is called tropylium ion. This is a tropylium ion which is also aromatic because it is delocalized, completely delocalized pi electron. How much? 6 pi electron. Molecule also planar. Molecule should be planar. This is very important, planar. It's not, it must be planar, must obey Hockel's rule, both points satisfied. And this case you see, this ring contains 6 pi electrons. Rings contain 6 pi electrons. So ring contains 6 pi electrons, it is also delocalized. And also you can do like this, both. That's why it is aromatic. And this one also aromatic, it is also delocalized here. So as it is delocalized, so it is also aromatic. Here, if you see, then here total electron is yours 10 pi. Here 6 pi, here 4 pi, that is 10 pi electrons. And it is also delocalized. Here 2 pi, and this is also, this part is also involved in the formation of pi bond. That's why it is also 6 pi. This lone pair involved in the formation of pi bond. That's why it is aromatic. After delocalization, the molecule becomes planar. This side is not planar, but after delocalization, lone pair, when it removes the lone pair, become plus charge, that's why become planar. So it is also, this is called pyrrole, this is called furan, this is called pyridine. You have to know the name of the common name of the aromatic compounds or some organic compounds. It is also delocalized. 6 pi electrons. And it is also 6 pi electrons. These three. Here lone pair is not involved, but it is also delocalized. That's why it is also aromatic. But this case also, this compound, if you see 2 pi, 2 pi, 4 pi, but inside the ring, if you take this one, this side, this is minus and this is plus. When this is plus, it is become 2 pi electron. That's what satisfy Huckel's rules. Don't count this electron. Only inside the ring total pi electron is 2 pi. And it is also delocalized because after the breaking of this bond towards oxygen, it become negative charge and carbon become positive charge. So it is 2 pi electron which is delocalized. That's why it is planar and also obey Huckel's rules. And this is called inorganic benzene, and this borazine, this is also delocalized because this lone pair will delocalize like this. So formation, that is also, you can say 6 pi. 6 pi inside the ring, that is inorganic benzene. It has also 6 pi delocalized electrons and planar set after delocalizations. And this is the very important case. If you see this case, this side is having 6 pi. And this 2 electron, if you count, this is 8 pi. But as this ring is obeying Huckel's rule and planar, so any one ring is satisfying the condition means it will be aromatic. And the first ring is satisfying the Huckel's rule, so it is aromatic. Whole ring, whole compound will be aromatic. So this is satisfy aromatic. It may not satisfy, but the first is satisfying means it is aromatic. This case, it is satisfying. That's why aromatic. And this case, if you see, here total number pi electron, if you count, it will be how much? This is your 6 pi and this is your 2 pi, that is 10 pi, and this is also 2 pi, that is 12 pi. But 12 pi is not satisfying, but it is satisfying if the molecule, this pi bond is breaks in this direction, then it will be plus, then it is minus. Then this ring is 6 pi and this is also 6 pi. After breaking of this pi bond towards the smaller ring, it will become minus charge, so it has remaining. Now it is delocalized. This negative charge can move in this direction like this. So it is 6 pi, it is also 6 pi. So this molecule is aromatic. So these are the important concept of aromatic. If they satisfy Huckel's rule and the molecule is planar, then it is called aromatic. But non-aromatic condition is it does not obey Huckel's rule. Huckel's rule means it must contain 4n plus 2 completely delocalized pi electrons, and molecule may be planar or may not be planar. There is no condition for that, but it does not obey Huckel's rule. That's why it is just opposite, non-aromatic. For example, this, it has 2 pi. But not completely delocalized. No delocalization is possible because no plus charge. That's why this pi electron cannot move toward this. As it has no resonance, that's why it is non-aromatic. It has no resonance. Here only one side is possible, but this side is not possible. So no complete resonance. Although it contains 2 pi, but no complete delocalization. That's why non-aromatic. And this one also, you see, here it looks like this. This part is delocalized, but it has how many? 4 pi. As it has 4 pi, that's why it is non-aromatic, because this side you see complete delocalization is not possible. That's why 4 pi electron means it is not satisfying Huckel's rules. That's why it is non-aromatic. And this one, no complete delocalization is here, and also not satisfying 4n plus 2 pi electrons. This is also 4 pi. Delocalization is not possible this side, but this side is no conjugation, so not complete delocalization. Here no complete delocalization. Here also no complete delocalization. 6 pi satisfying 4n plus 2 pi, but this 2 pi is not completely delocalized, only to this side. There is no further. That's complete. If complete delocalization is there, then satisfying 4n plus 2 pi, then it will be aromatic. As it is not satisfying the what? Complete delocalization concept, that's why it is non-aromatic. And this concept is very important, this one. What? It has, you see, 8 pi electrons. Delocalization is there. If you see, it looks like this. But if you see the actual structure, in this structure, that means in the 3D concept, if this is these two are in one plane, and these two in above the plane. This is the in one plane, and this two side is above the plane. That's why it is not planar. Non-planar. Non-planar means non-aromatic. Non-planar means non-aromatic, and that's why as it has no what? As these two sides are in different plane, cannot be delocalized. Delocalization is not possible because it is not in plane. If they will be plane, then delocalization takes place. Resonance takes place when the molecule will be planar. If the molecule is not planar, so the pi bond cannot be delocalized. That's why it is non-planar, so non-aromatic. Then come to anti-aromatic. Anti-aromatic molecule may be planar, but there will be no 4n plus 2 pi. Hockel's rule will not satisfy, but molecule must be planar. Molecule is planar, delocalization, you see, complete delocalization is there. Complete delocalization is there, but not satisfying 4n plus 2. 4n plus 2 rule is not applicable, but molecule is planar, molecule having delocalized pi electrons, but not satisfying the 4n plus 2 pi formula. That's why it is anti-aromatic. Anti-aromatic means just we can say opposite of aromatics, because in aromatic it must contain 4n plus 2 pi delocalized, complete delocalized electron, but it has 4n pi, not 4n plus 2 pi, 4n pi delocalized electrons, and molecule is planar. So that is one little bit difference. For example, it has 4 pi. This formula 4n pi, n is 1, n cannot be 0 here. Here n value equal to 1, 2, 3 like this. So 4 pi complete delocalization, and molecule is planar. Molecule is planar because pi bond means molecule is planar. This molecule, you see, delocalization is there, but it is 4 pi. 4 pi means not 4n plus 2 pi. 4 pi means 4n pi. 4n pi and complete delocalization and planar. These three conditions is very important. Planar, 4n pi number of electrons, and complete delocalization is there. And this is also, you see, complete delocalization. So it is how much? 2 pi, that is 8 pi. 2 plus 2 plus 6 to 8, 8 pi. That is 4n into 2, 4 into 2, 8 pi. But it is complete delocalization, 8 pi, not satisfying Hockel's rules. Here in this case, you see, delocalization also complete if this form, this is a keto form. This is keto form, this is your enol form. Keto enol form, you see, if this hydrogen is there, if it break like this and it go to this side, then it become double bond and wedge. And you see, this molecule is satisfying complete delocalization. And that's why complete delocalization, molecule is planar, and it is how much? 4 pi electrons, 4 pi. This, the pi electron converted to these sides. So this pi electron convert to this formation pi bond, so the complete ring is delocalized. Complete the pi electron is delocalized. A molecule is planar. planar and complete delocalized and satisfying 4n pi, not 4n plus 2 pi. So it is 4 pi. So this is anti-aromatic. So anti-aromatic, non-aromatic and aromatic, these are the different types of aromatic, different types of organic compounds, cyclic compounds. Cyclic compounds are three types, that is aromatic, non-aromatic and anti-aromatic. Only they differing in this particular properties. So, but if you see the stability is aromatic because it's satisfying all formula. 4n plus 2 pi, Huckel is satisfying, molecule is planar. That's why stability is more. Aromatic is more stable. Then non-aromatic. Na means non-aromatic. Then anti-aromatic. Least stable is anti-aromatic. AA means anti-aromatic. Least stable. Then Na means non-aromatic. Then aromatic. Most stable is aromatic. Then non-aromatic, then anti-aromatic. So like this concept, you use this concept in different examples, practice, then you can remember what are the properties of aromatic and non-aromatic and anti-aromatic. It requires practice. Then you will have better knowledge regarding the difference between aromatic, non-aromatic and anti-aromatic. Okay, thank you all.